Hey, welcome to math class where math makes sense. That's the goal. Welcome to math class where math's our friend. Feel the math love. Today we're feeling the math love about inverse. Switch your x and y. Inverse. The equation you can find. Inverse. Now graphically check. Inverse. It's over y equals x. All right, let's start out. Y equals 1 over x plus 2. Okay, friends, this is a rational function. It's a basic rational function, up to. Bing, bing. Here's my up to. There's my horizontal asymptote. And here is my lovely function looking something like that. By the way, these are not perfectly drawn. Notice a lot of it's not to scale. It's just sketchity sketch, right? General behavior here. Okay. So let's follow through the song lyrics. Switch your x and y. Bing. The equation we can find. Okay, that part means solve for the y. Like I need to find the y equals equation. What am I going to do? I'm going to subtract the 2. And then I'm going to multiply both sides by the y and divide by the x minus 2. And so I get y is equal to 1 over x minus 2. I like to tell my students, like, once you see this as a quantity, do the dance, right? So multiply by the y, divide by the x minus 2, and those switcheroonies. Great, and now we've got our inverse. Switch your x and y, inverse. The equation you can find, inverse. Graphically check, inverse. It's over y equals x. Let's check it. This is a rational function, right to. That's that transformation. And so I'm going right to, and I'm getting some sort of asymptote here. And so now my function looks like this kind of a thing. Okay. Oh man, I'm a crazy person. That's not what it looks like. All right. This one was up to. That one was right to. But it still has a horizontal asymptote of 0. So it goes. Okay. Brain. Okay. So graphically check, it's over y equals x. It's over y equals x. Y equals x is somewhere here, right? Right at that 2 and 2. Okay, so if we notice, we're trying to see that this x-intercept is this y-intercept. It is, right? We're noticing that this horizontal asymptote and this vertical asymptote are switched. They are, right? They are. So what am I saying? The yellow one has a horizontal asymptote of 2 and a vertical asymptote at 0. Now switch those. The purple one, instead of the vertical asymptote at 0, it has a horizontal asymptote at 0. And instead of a vertical asymptote at 2, or horizontal asymptote at 2, it now has a vertical asymptote at 2. Oh, my brain just got all switcheroonies. But that is what we see. We see all that switching. For rational functions, we don't see the reflection. I mean, that reflection wasn't quite as crystal clear in my little hand sketch. But you notice that everything switched. So the horizontal asymptote became the vertical asymptote, and the vertical asymptote became the horizontal asymptote. So this is the next part of the lyrics. Inverse swap, switcheroo, reverse all the things that rely on the x and the y. All of the points switch their x and the y's. All of the points, the domain and the range and the transformations. It's the inverse relation. This one went up to, right, from 1 over x. This one goes right to. Oh, left 2 versus right 2, the transformations got inverted. Okay, this one has a domain of all real numbers except x cannot be 0. This one has a domain of all real numbers except x cannot be positive 2. Well, this one has a range of everything except y is not 2. That's that horizontal asymptote. And for this basic rational function, it doesn't cross that horizontal asymptote. So it's 2. You can cross horizontal asymptotes. You can cross them. Just 1 over x doesn't cross it. And so a transformed 1 over x won't cross its horizontal asymptote. Okay. The range here is all real numbers except y is not going to be 0 because that's its horizontal asymptote. Notice the domain and the range switch. So inverse swap, switcheroo, reverse all the things that rely on the x and the y. All of the points and the, how does the lyrics go? All of the points, the domain and the range and the transformations. It's the inverse relation. Transformation switch, domain and range switch. Any point is going to switch. So if I plug in the point, let's plug in the point 1, and I'm going to get 1 plus 2 is 3. Well, let me plug in 3 here. And what am I going to get? 3 minus 2, that's 1. 1 over 1 is 1. Inverse swap, switcheroo, reverse all the things that rely on the x and the y. All of the points, every single point would work like that. The domain and the range and the transformations. Switch, switch, switch. It's the inverse relation. Okay. Hope that helped. This works for all inverses. It doesn't have to be rational functions. It can be linears. It can be absolute values. It can be any inverse relation. The thing that happens with things like quadratics that are not one-to-one functions, when I get the inverse relation, I get a 2-part root, a positive root and a negative root to make up the whole inverse relation. There's like other pieces and parts to that. But this idea of the inverse relations with everything swapping is all true always. Regardless if it's these functions or transcendental functions, if you got exponentials, you got logarithms, these things are inverses and they'll work the same kind of a way. Stream that song Inverse on Funky Functions by me, Math Love Sue. And share, subscribe to the YouTube, follow all the things, and don't forget, spread the math love because math loves you. Okay, bye.